So welcome to the Creatology Music Talk, Concepts for Computing Patterns in 15th Century Korean Music. And this is by Sukhie Moon of Sungsil University, Korea, myself from Aberystwyth University, Wales, and Ida Poo from Goldsmiths, University of London. Okay, so you met me during the introduction to this special track. I will just remind that I work in the combinatorial aspects of computer science, and in particular stringology, algorithms, and related data structures. Application areas are particularly bioinformatics, and more recently, musicology analysis. And this is probably a good moment to thank Patterns for continuing to invite me onto the program committee. Okay, so this talk is in two parts. So first of all, we will look at classical Korean music and a bit of the history surrounding. And then we will draw a link with stringology techniques and propose the analysis of Korean music via stringology methods. Okay, so King Sejong of the Joseon dynasty ruled according to Neo-Confucianism teaching. And so for this, he invented the yoke ideology of ruling subjects via courtesy and music. So for this, he invented a music score. And this was intended to help rule the subjects with kindness rather than through punishments, which sounds wonderful. So the music score has both a structure and notation patterns for recording the music, and we will look at both. So that will be the first part of the talk. And then we will propose applying stringology techniques, and stringology is the study of strings of data for analyzing these music scores. Okay, so what we see here is an instance of a music score, and do note that it's read from right to left. Now, a basic component in these scores is the jongan, which is a square, and squares are organized into columns, which is a heng, and then the total length of the column is subdivided into 6 daengangs, and each of those comprises 3 or 2 squares. And the squares are ultimately important. They're the building block, and they give the pattern for the music. So the score was first introduced by King Sejong, and then it was improved by his son, King Sejo, and it has continually evolved up until the current day. And so therefore this is of both classical and historic interest, but also of current interest. The music score is a full score, and it notates lyrics, instruments, and rhythms, a variety of rhythms, in 1/3 or 1/4 beats, for instance. So let's look a little bit closer at the music score. So as we know, it's read from right to left. If you notice in the top right-hand corner, there's a black rectangle. So that means that this piece of music has an incomplete bar. There is also a 5-column set. Now we notice that the total length of 16 squares are subdivided into 2 8-square parts, and the first 8-square part comprises the pattern 3, 3, 2, 3. The next column comprises the pattern 3, 2, 3, 3, 2, 3. And the little fives indicate that this is a 5-column set. So let's look at that. So this is a Jangonbo music column set. So remember, a square is Jongan, and so the type of music is Jonganbo. So these, the music score is a full score where the 5 columns make one column set. So reading from right to left, we first of all have in column 1, this will notate the string instrument giving melody. The second column is the wind instrument. The next 2 are the percussions. And then finally, we get the lyric. Now, in terms of notating these in the score, the percussion is notated by symbols of strokes, and the melody is notated using pitch. So let's consider the Neo-Confucian meaning of the structure of the music score. So King Sejong's version, the 32 square hang, means 1 year. And we've seen before the structure of 8 squares. And 8 squares gives you a season, for instance, spring, summer, autumn or fall, and winter. And the 8 is subdivided, as we've seen already, into 3, 2, 3, for instance. And this depicts heaven, human, or earth. So there's very beautiful meaning embedded in the structure of the music score. King Seju's version, the sun, the 16 square hang column means music, which was embedded in their political meaning. Okay, what about interpreting the rhythm of the music score? Now, this has been non-trivial, and it's been ongoing research since about the 1950s. And there have been various theories on interpreting this musical rhythm. But don't forget that back in the 15th century, there were no digital recordings and no vinyls to actually hear the sound of the music associated with the music score. So various interpretations have been, for instance, H. Lee interpreted 1 square as the unit of beat. Huang and J. Lee generalized this to each square having the same length. And there have been various other theories. This has been quite difficult to align their interpretation with the sound of typical Korean music. More recently, the first author, Sukhie Moon, has proposed a promising new theory, and we will see examples of those soon. And overall, don't forget our interest from the computer science perspective is implications for computational processing and interpreting the rhythms. So 15th century Choson music was in 2 types. There was dangak. This is music from China with lyric written in Chinese characters, which favors the binary subdivision of the beat. And hyangak, indigenous music of Korea, with lyrics written in the Korean language. So the music was recorded in the score with 2 different notation patterns. So we've looked at the structure, and now we're looking at the patterns. So with pattern 1, the melody, percussion, and lyric are notated in the unit of 8 squares, and in pattern 2, with 5 or 3 squares. So let's look at examples of each. So here we have a dangak example, notation pattern 1. This is a rhythm with the binary subdivision of a beat. So we see the music score on the left, and we see 8 squares making up a beat. So we have here 2 beats altogether, and we see the asymmetric half beats. For instance, 3, 2, 3. And we see the translation by Sukhie Moon into Western stave notation. And this particular piece of music is called Gimyong. And do be aware that the Western stave notation approach has been analysed since at least the 1960s using core computer science topics such as automata and formal languages. Okay, notation pattern 2, rhythm with a ternary subdivision of a beat. So this is a Hyangak piece of music. We see the score on the left, and we see the 4 beats in the heng, and it is subdivided into 1/3 beats. Here we have 2, 1, 2, 1, 1, 1. And again, the translation by Sukhie Moon. And as we conclude the first part of this talk, I would just like to say it would be nice if the musicians present in the audience would actually play Sukhie's interpretation of this music score. So moving on to the second part of the talk. So here is where we propose applying